Welcome to Nature of Code in Rust and GGEZ. This is example 1.9, Motion 101, Velocity and Random Acceleration. This is going to be exactly the same as the last example, except we're going to be having the mover update its acceleration randomly instead of hitting up or down or just constant. I did make a small change. I updated the vector in utilities to just be just do F32s. I'm no longer using generics there. We never really need anything other than F32 with GGEZ anyways. What that allows me to do is also write some nice documentation for it. And that shows up in the documentation here that we can generate automatically. The really nice thing about this is all of the code that we see here in the documentation for vector 2 is tested as part of the normal test suite. So if I was to open the documentation or to compile this, it wouldn't compile unless these documentation tests also worked itself. So I thought that's a really nice touch to ensure that the library is working the way we expect it to, so that way when we actually use this, it's doing what we expect it to. All right, well, let's get into the actual exercise, or I guess in this case, example. So we want velocity and random acceleration. So if we go into, let's see, in our main library, we don't actually need it to handle input in this case. So I'm just going to remove that. We're going to head back into our vector, not vector2, into our mover. And let's see, we no longer need to acceleration is set to 0, 0. That's fine. Then I want to, in update our, we want to update our acceleration randomly. So we can just do this right here at the beginning of update. So we can do that random number generator in here. So let's use RNG. Now RNG is actually supposedly expensive to create, so we can actually have this passed in. So RNG is going to be a mutable reference to a thread RNG, and then that's going to allow us to get the to set a random acceleration for ourselves. So we're going to do self dot and actually, how does this work? Oh, they're going to use random 2D. So if we take a look at the code example, they're going to do a random 2D method off of vector. Let's do that ourselves. So instead of having to do RNG ourselves, we're going to create a random 2D here. So we need to go into our vector 2 and create a function for that ourselves. So pub function random. This is not going to take in fact, this is sort of like a static class. I'm going to go ahead and make this near the top, near the other static method that we have, new. So pub function random. We're not going to take anything in, and we're going to return a new self. So we're going to first create, well, we actually can just call random off of here. That's going to give us a random number between 0 and 1. Okay, so we want let x equals random. We need to tell this that it's going to be an F32. And we set the same thing for y. Now, for each of these x and y's, we actually want to subtract by 0.5. So it's a number between negative 0.5 and 0.5. So minus 0.5 minus 0.5. Then we're going to create the vector. So vector 2 equals self new x and y. And then I want to normalize this so that the hypotenuse, the magnitude, is going to be 1. Right now, it's going to be, what, 0.5 squared plus 0.5 squared, and then take the square root of that. So let's normalize it. So vector 2 dot normalize, and then we're going to return that. So vector 2. And if we want to create the documentation, the way we do that is it's either going to be 3 slashes or this slash star star. This is going to be the doc comments. So create a new vector 2 with random values and a magnitude of 1. So if I want to actually run tests for this, we do have to do a use and go from the base. Like, we can't just say, use this. Oh, and it has to be, these are just markdown. So 3 ticks. And there we go. Okay, so use this, and then we can just let vector 2 equals vector 2 random. If we wanted to do any assertions, we could assert that vector 2.x is greater than -1 0, and vector 2.x is less than 1.0, something like that. So we can run this doc test, and it passed. So next time we compile the documentation, it will actually run this. So this gives us a normalized random vector, so pointing in a random direction. Let's come back to our update here, and we're going to get our acceleration, and we're going to, so let random acceleration equals vector 2 random. So it gives us that. Now we want to scale this up by some factor. The book suggests 2. So let's go ahead and do that. Immutable, then random acceleration, multiply scalar 2.0. Then I think that's pretty much everything we need to do, because acceleration is then added in here. Let's go ahead and we don't need to maybe make this, let's actually do this as self dot acceleration. So that way we're not creating a new variable, we're using that acceleration that already exists. So self.acceleration, we multiply the scalar, and then we add into it. There's not really a big difference, but it works with the rest of this. Okay, so if I save you, we only have we have a warning. Okay, we don't need this thread RNG here because that's going to be done over in the random function. So let's go ahead and run this. And here we go. A mover object that moves in a completely random direction with every single frame, it choosing a new acceleration between -2 and 2. And that is example 1.9, Motion 101, Velocity and Random Acceleration. Thank you so much for watching, and I'll see you in the next video. Bye.